Today we will discuss forced vibration with single degree of freedom system in vibration engineering. First of all, we consider a spring mass dashpot system which having spring, damping and have a mass m. A force F is equal to F naught sin omega t is applied on the mass m. The force will acting in downward direction. In spring, the spring force Kx will apply upward direction, which is the spring force, and damping force Cx dot will also apply in the upward direction. Inertia force Mx double dot in this spring mass dashpot system will also apply in the upward direction. Then the equation in case of spring force, damping force and inertia force is given by mx double dot plus cx dot plus kx is equal to f naught sin omega t. This equation is the double order differential equation. The solution of this equation will be x is equal to the sum of the complementary function xc and the particular function xp. Let the amplitude of this equation is given by small x is equal to capital X sin omega t minus phi. Phi represents the phase angle and capital X is the amplitude. Small x is the displacement vector. Now we get the velocity vector x dot by differentiating the displacement vector with respect to t. Then we find x dot or velocity vector is equal to x omega cos omega t minus phi. When we convert this equation in sine form, then we get minus x omega sin omega t minus phi plus pi by 2. That is the equation 4. Now we get the acceleration vector of the displacement vector or velocity vector. If we find out the acceleration vector from the velocity vector, then we differentiate the velocity vector with respect to t, then we get x double dot is equal to minus x omega square sin omega t minus phi. That is the equation is 5. By putting the value of equation 3, 4, and 5th in equation 1, then we get minus m omega square x sin omega t minus phi plus c omega x sin omega t minus phi plus pi by 2 plus kx sin omega t minus phi, that is equal to f naught sin omega t If we put the amplitude of acceleration vector, velocity vector and the displacement vector in the form of vector representation, then we get this type of diagram in which we can see that the amplitude in acceleration vector minus m omega square x and the opposite spring force kx leading the angle phi and the damping vector or the amplitude of damping coefficient that is led by pi by 2 from the acceleration vector. Here we can represent in the triangle form, that is kx minus m omega square x, f naught and c omega x. We know that here f naught is hypotenuse, that by the Pythagoras theorem f naught square is equal to kx minus m omega square x whole square plus c omega x whole square, that f naught is equal to x in root k minus m omega square whole square plus c omega whole square, and the particular function will be xp is equal to f naught upon root k minus m omega square whole square plus c omega whole square. If we common in the denominator term, xp is equal to f naught. If we take k in outside, then in the root 1 minus m omega square by k whole square plus c omega by k whole square. We know that k by m is equal to omega n square and c omega by k is equal to 2 zeta omega by omega n. By putting the value of c omega by k and k by m in the equation of particular function, then we get the value of x is equal to f naught by k in root 1 minus omega by omega n whole square, the whole square, plus 2 zeta omega by omega n whole square. If we take the value of f naught by k at the downside of the x, there the x upon f naught by k is the magnification factor, that is equal to 1 upon 1 minus omega by omega n whole square plus whole square of 2 zeta omega by omega n in root, that is the final magnification factor. Now we find out the phase angle, that is given by phi. We know that from the triangle tan phi is equal to, you can see in the diagram, tan phi is equal to c omega x divided by kx minus m omega square x, that is tan phi is equal to c omega k minus m omega square. If we divide by k in both sides, then we get tan phi is equal to 2 zeta omega by omega n upon 1 minus whole square of omega by omega n. Then we get the value of phi. Tan goes to right side and make tan inverse. Then the final value of phi will be tan inverse 2 zeta omega by omega n upon 1 minus the whole square of omega by omega n. Thank you.